In our practice exercise 12.16, which is even digits, we're going to write a method. It's called evenDigits. So let's do a public evenDigits. It's going to accept an integer as parameter, int n, and it's going to return the integer formed by removing the odd digits from our integer. So we want to return an integer. We take a type of integer as a parameter. So inside of here, again, we want to remove all of the odd values. To do this, we are going to recursively run through our n, and we're going to have a base case. In our base case, since we're running through every single one, is going to be if our n is 0. So if n is equal to 0, that means we're going to want to return, and we'll just return a 0. And that also has to do with all this down here, helping us out here. Otherwise, I think we could just return an n, because our n would be empty. So how do we get our n to be empty, or at the 0 part? Well, there's two other cases we need to take care of. Case if it is an even value that we're currently looking at, and if it's an odd value that we're currently looking at. And how do we determine if this value is odd or even? How do we determine which one we're looking at? Well, we're going to start with the back on each of them. And the way we can do that is take this entire number and take the modulus of 10 with it. And that'll give us this remainder right here, this value. So let's first check if it is odd, because if it's odd, we're just going to want to recursively run through the next value and completely omit this one. So if our n, and I'll have double parentheses, you'll see this in a second, y in a second, n modulus 10, right, because we want the remainder. If this value is odd, so if the modulus 2 does not equal to 0, this means that it is odd, means it has a remainder that is not 0. We want to return a recursive even digits where we pass in our n, but divided by 10. That way we axe the last part right there. Now, if it is even, we'll fall into an else statement, and the condition is basically this, but equals equals and not equals instead of not equals. So otherwise, we're going to want to return, and the first thing that we're going to want to do is go recursively through here again, right? So we want to return even digits n divided by 10, right? Because we want to look through the next thing, but we want to multiply this by 10 because we want to build this value. So what I'm saying is when we break out of our recursion, we're going to want to print this 8, right? Multiplied by 10. That way we can go to the next digit place and print this 4, then 2, and then 6. And then we want to append to this our n modulus 10, because remember, this is if we have an even digit, right? And if it's an even digit, we have to append this even digit right here. So let's say if we have something like 8426, right? We have this this return right here. We're basically axing out this one, but we're keeping it in the back for when we recursively come out. And then we would do the same, like let's say this is all we have. We would print this recursively, and then this again recursively, and this 8 again recursively, until we hit this base case where we would just unwind. And that's pretty much it. So let's submit this. Make sure you close off your method, which I have forgotten to do. So closing it off, we submit and we pass 10 out of 10 tests, and that's how we do this exercise 12.16, which is even digits.